All right, everyone, thank you for joining us once again on the ESCO Roadshow. On this adventure, we are headed to the Mitsubishi Chicago Training Center, just outside of Chicago in Schaumburg, Illinois. Mitsubishi has 11 Mitsubishi-owned training centers in Atlanta, Boston, Manhattan, Florence, New Jersey, Orlando, Houston, Dallas, Los Angeles, Chicago, Cincinnati, and Mexicali, Mexico, as well as 112 Mitsubishi authorized training centers at locations near you, primarily at equipment distributor locations. In the last decade, the Mitsubishi Technical Training Department has given 24,000 plus classes to over 355,000 students. That would be at over 3,000 locations with nearly 700 different technical training instructors. Total, they have delivered over 800 different HVAC and refrigeration courses. To learn more about all of the training opportunities available to you through Mitsubishi, visit MitsubishiComfort.com. All right, everyone. Thank you for joining us once again on Did You Know the ESCO HVAC Show. So we are hanging out here in Schaumburg, Illinois at the Mitsubishi Chicago Training Center. And I'm spending time with Bryn Raptor and Juan Cardona. How you guys doing?
Good. What's up?
We've had a lot of fun, and we're actually going to, I'm going to ask a few things of you. So in the chat, I want you to let us know where you're joining from. Yep. Oh, Austin too. Thanks for joining us, Ty. So we've had a couple conversations here, and I think we've come to the conclusion that almost all of us technical trainers have some pet peeves.
Oh, yeah.
Right?
Oh, yes.
Wiring was absolutely mine. I love having things squared and
Neat.
neat and trimmed, and but we hear a variety of different things. So if you're that way, let us know in the chat what things you're particular, because it's kind of a theory that all of us technical trainers have this kind of, I won't say, it's just an unusual mentality.
Yeah, for me,
Yeah.
zip tie was the greatest invention.
Oh, yeah, absolutely. Yeah, zip ties are a wonderful, wonderful thing. I've probably got 2,000-3,000 of them, different sizes,
at
different
least,
colors,
on a
different
good
lengths.
day.
Yeah, absolutely. Oh, and another thing we were talking about, really good thing. Hey, Paul, thanks for joining us from South Jersey. Oh, hey, Kendrick, CMHE, glad to have you here in Chicago. Todd Clur out in California. Hey, Katie, we were just actually talking about tutus to tool belts earlier, so glad that you're joining us from Hillsboro, Missouri. All right, so this is like super important, okay? Are we ready?
Yes.
So this was brought up by Bryn. When you're cutting a steak, do you hold the steak knife in the left hand or the right hand?
Yeah.
Your dominant hand or the other hand? I guess,
There
right?
you go.
So we'll leave that one in the chat box. Fill us in as we go, and we'll. All right. We'll get to the serious,
Important stuff.
That's right. Hey, San Pedro, thanks for joining us, Osvaldo. It's been a little while since you've been here. Glad to have you today. All right. So what we're going to do today, we're going to spend some time diving into inverters, right? So we're in this fantastic technical training facility, and I'll tell you, every single piece of equipment in this is inverter driven, right? Inverter compressors, inverter motors, because Mitsubishi understands the importance of training on the technologies that are coming to the industry. Like, we're changing very, very quickly. And we're becoming an inverter-driven industry.
Yes, and that's where we're headed.
Absolutely. Plain and simple. So we're grateful that you're all joining us. We know that many technical trainers are starting to update their classrooms and looking for inverter advancements, and that's what we're here to do. We're here to talk about Mitsubishi's products. We're going to dive a little deeper into inverters in general, what they are,
Yes.
how they function, and then we're going to get up and look at some different product lines and what we're doing with inverter technology. Is that fair?
Sounds good.
Okay. All right. And if you have any questions along the way, please let us know in the chat. Remember, we're here to serve you. We're here to
That's right.
help you along this way. I mean, that's
And as
what
I
we
tell
do.
all my students, there's only one stupid question in the room. Which is it? The one that is not asked.
Oh, yeah, absolutely.
Okay,
Every
so
question's important.
If anyone in the chat leaves with unanswered questions,
It's on you.
who's responsible?
That's right.
Exactly.
So bring them to us. We're here for you. So we're going to go diving into this. This is an abbreviated version of some of the things that you would learn in one of the Mitsubishi classes. But we really want to make sure that you're understanding those fundamentals of inverters. And so when we talk about an inverter, we think about these, especially in ductless systems, mini
Yes.
splits. Most people know most mini splits are operated by inverters, but even things like refrigerators are starting to utilize inverter
Absolutely.
technology, right? It's a very, very common process. But if we allow it to be misunderstood, it becomes difficult to comprehend.
Right.
So let's break it down and let's talk about it very simply, what we're doing in an inverter circuit.
Okay. So here's what we have. We have a generic inverter circuit.
Okay.
Okay. And, electricity 101. We have the source, which is the electrical supply coming into the outdoor unit.
Incoming AC.
We have the path, which is all the circuit boards.
Okay.
And ultimately, we have the compressor or the motor, which is the load.
Yeah.
So that's electricity 101.
Sure.
All right. So let's start beginning at the source. So in this scenario, we have 208 or 230 coming into the outdoor unit, single phase.
Right.
So the first component we come into in the equipment is the noise filter board.
To help clean it up a little bit.
Yes.
Yeah, because there's a lot of dirty power
To
on our
prevent
grid.
dirty power
Yeah.
and prevent harmonics and all that stuff.
Absolutely. That makes
So
sense.
we clean that up before we send it to the inverter circuit.
Okay.
So in the inverter circuit, we have the diodes or rectifiers or rectifier stack or whatever you want to call it, but it is a rectifier.
Okay.
A rectifier takes AC electricity and converts it to DC electricity. They allows it to flow one direction. And this is, again, this is a simulated circuitry here at the end when we get back to the compressor.
Back to the motor. Yeah.
Right. So we are converting AC to DC at first. But in that conversion, if we had an oscilloscope connected to the product, you could see that that DC signal is quite choppy.
Yeah.
You've got high
High
peaks and low valleys. So it's not really adequately to be controlled.
Okay.
So we need to send that DC signal to our smoothing circuit. In the smoothing circuit, two components are found: the reactor,
Okay.
which is like a choke,
Yeah, absolutely.
okay,
Yep.
and then the capacitors.
Okay.
So when you pair a capacitor with a reactor, we straighten that DC circuit line as straight as we can do it. It's
Oh,
still a little choppy, but not quite as bad as
when
it
it first was
was.
introduced.
Exactly.
okay.
There's only one component, Clifton, made on Earth that can generate a true DC signal. Do you know what that is? Don't overthink it. We probably have so many of them before us.
Oh my goodness.
It's the battery.
Yeah, a battery is a single path.
Yes, it's the only component made on Earth
Yeah.
that can generate a true DC signal. So this is a simulated. We're generating this DC signal. We're converting it. Now we're smoothing it.
Okay.
Now we need, before we send it to the compressor, we got to send it through our inverter circuit.
All right.
In our inverter circuit is where the IGBTs are found. Would you like to know what IGBT stands for?
Of course. Integrated
Okay.
gate bipolar transistor.
Very good. You've heard this before, haven't you?
I have. I'm a nerd like that. I love this stuff.
That is good stuff.
It is.
Not only IGBTs, but they're also called triacs.
Okay.
That's
I have
another
heard that
name.
term. Yes,
Another
I have.
name for it.
Yes.
So you could see in this design, you've got 3 on the top and 3 on the bottom,
Okay.
where the 3 on the bottom are actually adding the bottom wave back to the sine wave, because we are going from DC back to AC.
Oh, okay. So that's where we can go above our ground reference and below our ground reference
Correct.
to be able to get that simulated sign. I never actually
Yes.
picked up on that. So that lower set of IGBTs is finishing that DC sine wave into an AC looking sine wave.
That is correct. That is
I don't know
correct.
how I missed that, but I did. I
Well, now
completely
you know.
Now I know. Did you know?
Good point.
Somebody
there.
will pick up on that.
Somebody should. So, but the reason why we have 3 is because we are simulating a 3-phase balanced signal to the compressor or the motor.
Yeah, absolutely.
And I speak to many technicians that are wanting to know a number. Well, the number doesn't matter. What matters is that all three pairs reflect
Same.
the same number.
Yeah,
U to V, V to W, U to W.
absolutely.
All three pairs must reflect the same number plus or minus 10%.
That was a good point. I've had people ask that before, is what is the tolerance on that? And I say, well, typically in our industry, we design things for approximately a 10% tolerance, plus or
Yes.
minus 10%.
Absolutely.
And that's usually what I would tell people, because I get a lot of people ask about that 300 volt range. And it's actually, when we start thinking about it, like most of our meters are true RMS, root mean square meters, and we're reading an average voltage, not realizing that those peak voltages on a 240 might actually get up there into the 300.
That's right.
So we're utilizing those peak voltages, building that into a DC voltage, storing it into a capacitor. And so we actually do see that, because even on the, like if it was a 120 volt system, we won't see 300 volts. We'll see approximately 130% of that incoming 120. Right. So most of the time we're going to be working on a 240 volt system, and we will see about 300 volts DC. Yes, now absolutely. That the voltage going to the motor, may not be that.
It's variable.
Yeah, exactly.
Because we never know the demand that the system is under.
I get that.
So we don't look for a specific number.
Right. Consistency.
Right? Correct. And the beauty of the inverter, you want to know what the beauty of the inverter is?
Yes.
Okay. Thank you. Took you a while, but I'm glad you responded really quick.
Yeah.
So what is the frequency coming into the outdoor unit?
Well,
in the United States,
60-ish hertz.
60 hertz if it's clean.
Yeah, exactly. That's why I say ish.
Okay. So now, once we come out of the inverter, we can manipulate that frequency.
Right.
All right. So if we want to slow down the speed of the compressor, we can slow down that frequency or lessen the frequency going to the compressor. If we want to speed it up, we compress that signal so that compressor ramps up in speed. So it's constantly looking at demand, and that the inverter is what depends, what is sending that voltage, because it is AC voltage when we look for it,
right,
to the compressor or the motor.
Okay.
So, and also another thing you see in this design is a microcomputer. And all it is two chokes where two wires go through. And that's what I call my amp probe.
Yeah. So
I'm monitoring
what's
draw.
happening.
Yes.
Yeah.
Yes.
Very true.
And that's how, and I get a lot of technicians asking me, well, I can check a lock rotor compressor with my amp probe.
Yeah.
And I said, you won't see it in an inverter circuit.
No, not at all.
Because the inverter will see it a lot quicker than the amp probe will do it. So you won't be able to see it.
Yeah, absolutely. And by utilizing two of those legs, we're actually crossing over those three sets of windings. And so we're getting a combined amperage reading off from that motor.
Again, back to the electricity 101.
Yeah.
If one leg is suffering, the other two are going to suffer as well.
Absolutely. So now we're able to variety of things. We can look at locked rotor. We can look at imbalance of the motor as well. If we know that we have good clean power coming out, but yet we're drawing varying amperage on different legs, we may actually have a winding issue. But very rarely, and I think that's a thing to stress to people, is the beauty of an inverter is that we're using a three-phase motor.
Yes.
We're not talking about a permanent split design motor that is going to fail on a leg if it has a component failure like a capacitor.
Right.
Three-phase motors rarely burn out. And so by modulating into a three-phase scenario, we get super long life out of these when installed and maintained properly.
Right. And on top of that, when you're doing an electrical test or on the compressor, what are you looking for?
I should have the same resistance between the three of them.
V to V, V to W, V to W.
Absolutely.
It's a three-phase motor.
Right. So my power should be consistent and my winding should be consistent.
That is correct.
And so it simplifies the diagnostics, actually, when we get into working with an inverter. Now, there are a few more things that we can check, but the tolerances are much tighter and more consistent. And when we understand how they work, well, now it's just a matter of getting comfortable with a new service procedure.
Yes. That's right.
Yeah.
And now my counterpart, Bren, is going to take this circuit.
Yeah.
And he's
going to tear it apart?
Yes, sir.
All right. I'm looking forward to this. All right. And we hope that you all are gaining a lot of information as we go along. And if you have questions, like I said, please let us know.
Yeah. Shout out to Paul for getting battery for the only place we source DC voltage from.
Yes.
Paul got it in the chat. Good job.
Paul is on it all the time. I've seen that, Paul Leonardi. Thank you.
So what I want to get kind of more into is the IGBTs. So we have our diode stack, right? That's how we convert to the DC voltage.
Right.
We have our reactor with our capacitors. Essentially, those capacitors are just filling in those peaks and valleys to allow for a much more straight line of what we want to see for DC voltage.
Makes
But then
sense.
we hit these IGBTs. And like Juan was talking about, we're essentially with a pair of those IGBTs, 2 for each leg of that compressor. We only have DC voltage, so we can only feed one side of that sine wave. So we
Right.
need 2 to be able to feed both sides of that sine wave.
Right.
So
Okay.
the easy way to think about an IGBT is just a switch.
Yeah,
It
exactly.
just can open and close so much faster
Very fast.
than a manual or mechanical switch. These are incredibly fast, incredibly high voltage too. That's
Mhm.
why we don't use things like MOSFETs. MOSFETs typically can't handle as much
The load.
voltage.
Yeah.
Yeah, as something like an IGBT. So that's why we
Huh.
use them.
All
And
right.
so that's the great thing about using these IGBTs. If you want to go to the next, we'll actually show how these IGBTs are creating that sine wave. So if we were to just take those IGBTs and open them one time when they're trying to feed that part of the sine wave, what
Mhm.
you'll see is this kind of square off sine wave. You don't get that nice flowing, sweeping sine wave because if they just open and close one time, there's no modulation.
Yeah, there's no
between there.
variability
Yeah,
between it. Yeah.
exactly.
Right.
So
Just a
we're
switch.
just kind of getting this opening and closing.
Right.
So what we actually do with these, and if you want to go to the next, I'll show you what we actually do with those IGBTs is they are actually going to open and close almost like in a pulsing. It's called pulse width
Pulse width
modulation.
modulation. Yeah, we talk about that quite a bit.
So we're
Yeah.
actually opening and closing that switch
At different timing.
larger variables in
Yeah.
order to get more of that sweeping sine wave, and that's what's
Sure.
allowing us to get that actual AC voltage. We could probably use the square sine wave, but it's not going to be nearly as efficient, nearly as effective. By doing this pulsing with that IGBT opening and closing together to feed each part of that sine wave, we're getting a nice clean AC voltage to that compressor, and it's going to
Wow.
act just like AC voltage.
That's
Technically, it has the characteristics of DC voltage, but it's AC voltage. You can measure it in AC voltage. It's going to be, yeah.
and that's
exactly.
the reason we call it a simulated AC.
Correct.
Right? That is a really good representation because I've seen the DC blocking before, but never thought about and I know the pulse width modulation. I
Yeah.
just never really thought about varying that voltage to be able to stack it to be able to create that sine wave. But that's a super good representation of what we're doing.
Yeah. So the length of time that switch is closed is going to create the
Yeah.
different portions of that wave. So just
Absolutely.
to create that bottom half of that wave, we are opening and closing that switch at longer or shorter intervals in order to get that part of the wave and actually have it be a waveform instead of that squared off where we open it once, close it. That's what's going to give us that square form.
Right.
By doing that pulsing, we're actually getting that nice smooth sine wave.
And so we can change the frequency simply by bringing together
Yeah.
our
Squeezing it
our
or
peaks and our
stretching it.
valleys.
We're just going to
Oh,
accelerate how fast we pulse
Yeah.
in order to close up that sine wave, giving us
Absolutely.
that higher frequency.
gives us the variable frequency drive.
Yeah.
Really, it's really what we're doing with it.
That's what it is.
Yeah.
Right. And obviously, the whole point of all of this is efficiency.
Yeah.
Right? If we only use 60 hertz, we're either on or off.
It's like
It's
a light
either
switch.
running at 60 hertz or it's not. This
Yeah.
allows us to, if we don't need all 60 hertz to maintain space temp, we'll run at 30.
Right.
And we can coast along at 30 hertz in order to maintain the space.
Mm-hmm.
We're using less energy. So it's ultimately more efficient.
I love it, Ty. It is interesting. I mean, it kind of follows exactly like what we were doing last week, talking about infrared. Like, so we're using basically it's a form of pulse width modulation from an infrared remote control. We're just using light to be able to control the signals that we're using. Now we're just going to be using voltage, DC voltage, built into portions that will modulate above the reference of ground and below the reference to ground, and then it completes it into a full AC sine wave. Because we get that question all the time: is the inverter motor an AC motor or a DC motor? You guys get that often?
Yes.
Yeah, it is exactly both. I'm so glad you said it that way because a lot of times I'll go, "Wow, it's DC voltage, but we're really using it in an AC." But I've never really sat down and came up with a very clean, simple way of explaining that it is DC voltage running an AC winding.
And that's
That
how I
is.
explain it, Clifton, is like I know many technicians have replaced an ECM motor either in a variable, excuse me, speed air handler or a gas furnace.
Right.
So back in the day, when one failed, you would just replace the module.
Yeah.
So when you separated the module,
Yeah.
what was in there. It
Three-phase
was a
motor.
plug with 3 wires.
Oh, yeah.
Because the motor portion of it was a 3-phase motor.
Yep.
The module was your frequency drive.
Yeah.
Right.
Absolutely.
So that's where the inverter was.
You ever seen my ECM exercise bike?
I have not.
We'll have to talk
we'll have
about
to take a look.
That's
at
a
that
whole
one.
nother
Yeah,
conversation.
we'll
Yeah.
have to go look
Yeah,
at
because
that.
an ECM motor, just the motor without the mod,
Right.
is a 3-phase motor,
It is.
which moved backwards is a 3-phase generator.
Yes, it is.
So I've got a 3-phase generator off from a half-horse ECM. But that's a whole nother conversation.
That's awesome.
All right.
You're R&D.
Oh, everyone's like, you're so smart. I'm like, no, I just donate my time to chasing useless facts.
You're a tinker.
I tinker. Well, I'm so glad we talked about it from that perspective. And I hope that helps clarify to everyone what we're actually doing in that inverter. It is a 3-phase motor.
Yeah. So this is just kind of showing what is actually happening, so we understand more now how those IGBTs are making that 3-phase AC.
Okay.
So this is actually showing the path of electricity, right? So when we have our UP, our VP, our WP, we'll call that positive.
Yeah.
Right? Our UN, VN, WN, that's our negative. And while we're pulsing, right, each one of those times those IGBTs are opening and closing,
Yeah.
we're getting about a 60-degree rotation from that compressor.
Sure.
So we need a place for that electricity to enter and exit.
Yep.
And so by closing those switches, we're creating that path. And we are basically going in certain patterns. So pattern 1, right, we're energizing UP, we're coming back on VN. Pattern 2, we're entering on UP, we're coming back on WN. And so we go through, every time we go through that path, we are moving that compressor 60 degrees. And so obviously, in this diagram, we've got 6 total patterns giving us that full rotation.
Yeah.
In reality, this is happening much faster
Fast.
than
Like,
we can
very,
imagine.
very
That's
fast.
what I'm trying to explain about the IGBTs. Is
Yeah.
you can see the pattern at which time those switches are coming on. And again, they're pulsing. They're not just open, close. They're pulsing at that stage. And we could be anywhere from 30 hertz all the way up to, with like some of our hyperheats, up to 127 hertz. So we're talking
Over ramping,
Yeah,
overdriving.
exactly.
Oh,
We're talking,
I love that. Yeah.
really fast, and that's how we drive that compressor.
Mhm.
That's how we're able to get those low ambient temperatures and still be able to make heat, is because we can work.
We
those
can
compressors
overdrive
really hard.
those a little.
Yeah.
Yeah.
Yeah,
Well, because
exactly.
if we only have 60 hertz coming in, that's all we can drive. And now that we start looking at going past that total frequency and speeding them up a little faster, that means we get more capacity out of that compressor.
Absolutely.
Yeah.
Right. I really like that. Something that just came up too, Todd and Ty both. Yeah, you're right. This is one of the best explanations I've ever seen on it. And it also adds another character. I might actually have to borrow this because when I see that, I am
How many bikes do you have?
oh,
It'll take maybe 2.
two. If I see this, I get the question all the time, what is back EMF? What is back electromagnetic force, right? When we're just talking about that 3-phase ECM motor, if I apply power to a 3-phase winding, I will get locomotive force.
Right.
I'll convert to locomotive energy. If I go backwards and I apply locomotive energy to my windings through the rotor, I can generate voltage.
Sure.
So in this exact rotation, if we look at number 1 and we're applying power to the IGBT through the top and through the left, the 2 red windings, that means that we have that potential to produce a little bit of voltage on that additional winding, which is actually our back EMF. So this is actually a really good diagram to explain what back EMF is and how it's reading, but boy, it's got to read just as fast as we're applying. I mean, there's a lot to calculate in there in that processor.
Yeah.
Really, really good
Absolutely.
stuff.
So yeah, you can go to the next one. And this,
Okay.
we don't have to spend a ton of time on each particular side, but this
Mhm.
is just kind of showing, again, a little bit more in depth as far as what we're looking at, what each leg is doing and how we're getting that rotation. So when we close, so now you can see actually when we come in on the top left there, that is our IGBT. You can see your collector, you can see your emitter, and you can see your gate. So we close UP,
Close
we
it,
come
feed
in
it through.
our U leg,
Yep.
back through our V leg, and VN is closed.
Yep.
So that's giving us that AC path, right? If it was DC, we wouldn't have the ability to always have that path back.
That full path.
So, right, exactly. So every time that those IGBTs, and as you scroll through, you'll see it switches, different switches in order to make that rotation. Now we're going to energize the W, and that's going to give us our path back on W. Every time we do that, we're just getting that rotational force on that compressor. That is how the compressor is driven.
You know, a lot of people talk about like the early ECM motors that would rock back and forth trying to
Yes.
hunt for
Yeah.
position.
Oh,
Yeah, that's
Yep.
exactly what they were doing. So they were looking to find the proper resistance to be able to learn its rotation, because an inverter board can run that motor whichever direction it wants to, because it's a three-phase motor. So it's looking for correct rotation on
And
that.
to stop that rocking back and forth, what we do internally in our compressors is we use neodymium magnets.
Mhm.
So when the compressor stops rotating, the magnets will find the pole and land there. So when it starts again,
It knows
we're
where it's
not
at.
rocking back and forth.
Yeah, it's already there.
Yes.
Yep.
So that extra strength of the magnet keeps the poles in place,
line.
and they cannot shift away, which we've seen with iron fair. Oh, wow.
Yeah.
This is a great class. I'm really enjoying this.
So yeah, this is pretty much all we have. It's just showing the different patterns as we move through, just showing those, IGBTs closing and how that changes the path and how that's creating that rotational force on the compressor.
Sure.
We'd mentioned earlier, we're looking for balanced voltage. That's the most important part when we're
Yes.
testing the
Right.
inverter side, right? When we're testing compressor, that doesn't change with any compressor, right? We're
Mhm.
going to ohm across windings, and we're going to check for shorts to ground the same we would with anything else.
Right.
When we're testing our inverter, really we're just checking AC voltage on each leg of that compressor, making sure that we're plus or minus 10% on our residential. You'll see in some of our service manuals on the commercial, they're looking for even tighter tolerances. You may see
5%.
plus or
Oh,
minus
really?
5 or even plus or minus 2 in some cases.
Wow.
So yeah, we're looking for a nice, tight, balanced AC voltage. And
Okay.
so, I get the question a lot, my voltage isn't balanced. And sometimes I'll get students say, oh, bad compressor.
Not
No,
necessarily.
right?
Right.
We need to
We need to
we need to
verify is the
isolate,
power.
right? We need to
Right.
separate those two components. Let's
Yeah.
test each leg of the compressor windings without them connected. Let's test the U, V, and W wires without them connected to that compressor.
Right.
Make sure we're balanced.
Because if the resistance is balanced electrically, the windings are in good condition.
Correct.
Mhm.
Yeah. So to avoid compressors being diagnosed as bad when
Yeah.
really it's an inverter issue.
Yeah, it's a board. Yeah.
Yeah, we got to make sure we isolate the components, and
100%.
check for that balanced voltage, and then when you do find imbalanced voltage, we don't just replace the board and move on. We got to make sure we figure out what happened.
What
Yeah.
caused
Right.
it?
What caused that
Yeah.
issue to
Why are we
begin with?
unbalanced? What happened?
It
Was
would
it
have
too
been a
much?
chain reaction.
Yeah. Exactly.
Well, I know in my area, we have a lot of dirty power. We have a lot of very long power runs, especially in the rural areas, that gets very low voltage. Frequencies can get off a little bit. And so I personally recommend using a good three-phase monitor and conditioner, or single-phase monitor and conditioner coming in to my outdoor unit, just to help clean that up. So I think we'll see a lot more of that going forward, because, yeah, I mean, bad power in equals bad power out.
Yeah. Yep. Yeah, we make a big case for that. If you come to our training, we talk a lot about paying attention to that incoming voltage.
Yeah.
And you did touch on it when we go through that diode stack.
Yeah.
We go through our smoothing circuit where we hit those capacitors. We have that power factor 1.41.
Yep.
And so we're looking for that 300 volts DC. If we have too high of incoming voltage, we've affected that power factor. And that tends to be what can take out boards, right? Because no matter what our incoming voltage is, it's always going to be in relation to what our DC voltage is coming out of that
Absolutely.
converter stack.
Sure.
And so the high voltage DC is what can take out boards. So we do want to make sure we check our incoming voltage, because it can affect the entire inverter circuit.
And
Yeah.
another beauty of the inverter is when in those occasions that we have high incoming voltage, the inverter will see it
Mhm.
and actually ramp the compressor down. It'll keep it running, but ramp it down. So the customer will not get full capacity cooling. So they'll call the contractor and say, my system is not cooling. So in our industry, typically, the typical technician will come to that call and do what? Hook up the gauges. Okay? Not even checking voltage.
Must be low on charge.
You
that
think?
be-
And
yeah.
so, because the pressures will be lower than normal.
Absolutely.
Again,
Because it's
because the
running lower.
compressor is running at a lower RPM, lower frequency. So they'll put refrigerant in it.
Yep.
And then walk away. And then once the voltage stabilizes, the ramping up begins. And then that's when the high side pressure goes way up. Always check voltage first.
It makes 100% sense to me, and I've never thought of it from that perspective before. And it completely sheds light into, why, because people say, why do boards go bad? Well, it's, typically it's a voltage issue.
Dirty voltage.
It's either voltage or water. It's typically what we see in most of the industry.
Yeah.
So Ty, that's a good point. What do we recommend for voltage? Like, what is a range is on our incoming voltage? I know we typically have a window range, but if we're experiencing voltage, high incoming voltage, what would be a good solution for that?
Well, the range, typically, the equipment is rated at 208, 230.
Yeah.
And typically it's plus or minus 10%.
Yeah.
So it's like 187 to 253 is
Yep.
the range. So if you're experiencing higher voltage than that, what I recommend is a buck boost transformer.
Yeah,
exactly.
Ty nailed it. on
It's
the
the
head.
only way to do it.
Yes, exactly.
Because no matter what the voltage coming in is, you always have a consistent, constant voltage going to the equipment, which is the best thing to do.
Yeah, absolutely. I know in my area, because of those long runs of power, now
Yes.
the municipalities will not tell you
No.
that this is what they do, but they absolutely elevate voltages on some of these long runs, knowing that there is going to be voltage drop over these extremely long
Sure.
runs, especially in rural areas. So I have witnessed myself in town voltages being high, and the same line very low voltages by the time you get to the last home. And it's very important to look at that. And so I think I mean, there's a lot of to bring away information, but checking that incoming voltage as the very, very first thing on
The first thing, absolutely.
Yeah.
And when you said that you live in an area with dirty voltage,
Yeah.
I'm thinking that must be anywhere in the United States.
And I think we're kind of getting there,
Yeah,
you know.
it's never consistent.
No,
No.
it's not. I just had a conversation last week with a rural electric co-op, and they're starting to incentivize on their own for their consumers to be able to upgrade to high efficiency heat pumps, inverter driven high efficiency heat pumps, because of the cost associated with upgrading the electrical grid. And so their 10-year plan is to convert more customers versus upgrading electrical grids. So I think we'll see a lot more of the bad incoming electrical. Matt just asked a question. Where do I find the complete presentation? You'll be able to come back to LinkedIn, YouTube, Facebook, our learning site on our HVACR learning network. I'll share some of those resources, but I'll end up cleaning this up and then putting it as a finished video, which will be available. I'll probably have that one done tomorrow. So yeah, go check us out on YouTube, ESCO Institute, HVAC Excellence. Hit notifications, turn those on, and then we'll go live every Thursday. You'll get notifications, and then we'll have all those previous episodes for you there as well. So yeah, good question, Matt.
And just a shameless plug here. Also, Matt, if you want to come to one of our training classes,
There you
every
go.
single one of these slides is from our training classes, especially or particularly our advanced M&P class. So if you do residential work and you are looking to actually be able to sit in a classroom, be able to raise your hand, ask questions, all of these slides are from that class. So we'd be happy to have you come in and spend the day with us.
Yeah, and that's something we need to talk about, you know, probably a couple times in here. I hadn't realized how many training Mitsubishi actually does. I mean, we don't think about a manufacturer doing, let's go back and look at these numbers. Like the tracking just started in 2013. Since 2013, you guys have had 355,000 students come through classes for Mitsubishi. That's a lot of technicians and students. Now, I highly encourage our educators, as you're starting to implement products into your classrooms, reach out to Mitsubishi, get in these classes and get a grip on what's happening and start making some connection with other industry trainers. You're going to be at the National HVACR Education Conference.
Absolutely.
We want to have classes diving deeper into this. All of these types of training are what we do every week. We bring these to you from the firsthand educators, because I'm telling you, there's information that I have heard here before, and I've never heard it exactly like I do today. And it impacts me as a learner, as an educator. So yeah, get your butts in seats.
It's the best way to learn.
That's exactly right. All right, let me hop out of here real quick. All right, so now we're understanding how we're flowing through that inverter circuit.
Yeah.
There's a sequencing all the way through, making our rotation. And let's talk about some of these parts that we have here now that we have a better understanding of how they're actually functioning.
Yeah. Yeah. So We did discuss this a little bit already, but when it comes to compressors, obviously you want to pull up the service specific.
Yeah, get the exact
manual.
resistance for those windings.
Yeah, find your unit specific manual. Once you pull it up in this, like particularly our service manuals will always have what ohms readings you should be getting. So depending on the size, you're going to ohm out across those windings. Verify that you don't have shorts across windings. Checking for shorts to ground is no different than any other compressor.
Yeah.
Right? We're just going to use our megger, check for shorts to ground. So there's nothing out of the ordinary there. It's very straightforward when it comes to diagnosing compressors.
And checking mega ohms. You need to be aware that liquid refrigerant is
Yes.
conductive.
conductor. Yeah.
Oh, yeah. So mainly on startups, if you're installing an inverter compressor in the winter and you don't power up that outdoor unit for at least 12 hours and you start it up, you will have an immediate, a dead short because you're going to power the compressor
Through the
and you've got a
potential
crankcase
refrigerant.
full of liquid. It's a potential short right on startup.
Yeah, you'll actually even notice on that particular site, it's telling you the rating at a specific temperature.
Yeah.
We used to have an instructor, Sean. He would put a compressor that was perfectly fine in the freezer. It had a little bit of liquid refrigerant, and he'd put it in the freezer in the morning, and he'd ohm it out in the afternoon and show that it was testing bad.
Tie. There we go, buddy.
And then he would let it thaw out throughout the day, then test it again at the end of the day and show that it's fine. So that liquid refrigerant can act as an insulator and cause some problems. So
I love that.
Yeah.
That's a great class.
Yeah.
Well, I'll give
He's a
Ty
smart
like
guy.
next week.
Shout out
it'll,
Sean
it'll be out there.
all right, well, I'm going to pass this off to you for the next couple.
All right. So here on this one here, we're talking about outdoor fan motors.
Okay.
Now on this specific unit, this is an MUZ. This is probably the only unit that has two connectors from the motor. One connects to CN 932 and the other one connects to CN 931.
Okay.
As you can see, the CN 932 comes, the inverter is in the circuit board, not the motor.
Sure.
So we have balanced three-phase power coming out of the board on CN 932 going into the motor.
Feeding directly into the motor. So you have a direct connection from your inverter control to the motor
To the
itself.
motor.
So all we have is a three-phase motor.
That's it. That is it.
Well, that's pretty easy. We just talked about how to troubleshoot them.
Right. Now,
Yeah.
CN31 is your rotational feedback.
Yeah, absolutely.
So when that motor is rotating, it's sending a signal, in this case,
Volts
is
DC.
5 volts DC,
yeah, absolutely.
back through that plug into the board, and that's how the board knows that that motor is rotating.
Okay.
So, and all that is in the service manual.
So we're just checking three-phase power, making sure that we have consistent three-phase power coming into the motor, and then we're just checking for that 0 to 5 volt DC across our pin terminals.
Correct.
That's it.
Simple.
Yeah. So all of our City Multi outdoor unit fans, they run just like our compressor does.
Yeah.
So they go
Balanced
through an inverter,
voltage.
and they have that balanced three-phase AC voltage. We do actually have one residential unit too, which is our FS units.
Okay.
Those also have a balanced three-phase
true
AC.
three-phase
Yeah.
motor.
Yep.
Yep.
One thing before you start going happy and wild
Yeah. Doesn't
with
take much.
test leads on our connectors,
Yeah.
highly recommend you get you a set of needle leads.
Oh, the little micro leads.
Because
yeah,
if you force a standard set of leads on our connectors, you're
Yeah.
going to be buying a board or a wiring harness or both.
I gotcha. Yeah,
So-
I completely get
If you
that.
thought it was broken before, it definitely is after you
Yeah.
shove the-
Oh, yeah.
Don't use the needle.
Oh,
Yeah, it's kind of like putting your thumb in your nose instead of your pinky. It just
Exactly.
doesn't fit.
This one here is most of our outdoor fan motors.
Okay.
It's a 7-pin connector.
Yep, seen that.
Pins 2 and 3 are missing.
Yeah.
So there's separation between pins 1 and 5.
Or okay.
Pin 1 is DC positive. Pin 4 is DC negative.
Sure.
That's where your 300 volts comes out of the circuit board into the motor.
Okay.
In this scenario, the inverter board is inside the motor.
Yeah.
So it's
I get
going to
that.
take those 300 volts DC inverted into a simulated, balanced 3-phase signal going into the windings internally.
Okay.
So pins 4 and 5 is also an output from the circuit board, which is 15 volts DC.
Okay.
Okay, which you'll see.
That's your feedback again.
We'll use that signal again.
Right.
Pins 4 and 6 is your speed command.
Yeah.
And that signal is 0 to 6.5. So if it's 0, that motor should not be running. If it's 6, that motor should be turning almost to high speed.
Looks like a variable speed ECM to me.
You think?
Yeah.
Okay. And then 4 to 7 is
Mhm.
that 15 volts DC signal coming out of 4 and 5.
Yeah.
Again, that's a rotational feedback being sent from the motor back to the board,
Know how fast we're
because
running.
the board, well, and it's a deflection, 0, 15, 0, 15, 0, 15.
Okay.
Most meters will not see that signal because that
Ah,
motor is going to run so fast.
okay.
Some meters will be able to display 7.5 volts DC, which is the average.
Did you hear that, Ty? I happen to have 6 meters sitting on my table. Well,
And not all meters are the same.
that is so true. A lot
Yeah.
of people don't realize that some meters run faster than
Yes.
others.
The best way to check and test the signal is to stop the system from running,
Yeah.
leave it powered up, put your leads across 4 and 7, and turn the fan blade by hand.
Ah, absolutely.
And then you'll see the
we'll just
deflection.
generate our
0.
own voltage.
That's it. That is it. Easy peasy.
I'm so glad we're doing this. There's going to be a lot of people going out. Why have I not brought these into my classroom
Exactly.
before? And it's, yeah,
Right.
I love this.
So, Brand, you want to take over
Sure.
on this one?
Yeah.
All right.
So right now we're looking at indoor fan motors.
Okay.
Here's the thing. Whether it's an indoor fan motor or an outdoor unit fan motor, we never change the order in which we pin out our connectors.
Oh,
So
yeah.
in this case, if we look, it's a 6-pin connector, but the order doesn't change.
Right.
So anytime that we look at a motor connector from one of our residential units or indoor fan motors, all we have to do is find the gap.
Look for the one on its own.
Yep.
That's going to
Look
be
for
your
the
feed.
gap, and that's your power in common.
Yep.
And then it's always feedback in, speed control, feedback out.
So I learned how to work on one.
Yes.
I've learned how to work on both.
Correct. If you can remember the order, that's much more important than remembering your pin numbers.
Well, yeah.
Because whether it's a 7-pin or a 6-pin, we're always going to leave a gap between our high voltage, because what does a high voltage DC like to do? It likes to jump, it likes to arc. So we
Exactly.
give you the largest gap we can for you to get your needle leads in there without potentially, creating a little boom.
Sure.
So, between pins 1 and 4 or pins 1 and 3, that's always going to be your high voltage DC. So we found our power in common right away. Now we just need to go in order: rotational feedback in, speed control, feedback out. Same order every time.
All in DC voltage.
Yep.
Yes. Regarding controllers.
Yes.
I mean, not controls, but connectors. One thing that I harp the most to the students is, don't let me catch you pull a connector with the power onto the board.
Yeah.
Because what is DC positive always seeking?
Oh, it's always heading to
The
ground.
ground.
It's always searching for
Absolutely.
ground.
So when you pull that connector off of that board with the power on, it's either going to shock you because it's going to look for the closest
Trying to
ground,
jump.
okay, or it's going to find a grounded screw
In
on
this-
that board,
Something
and it's
close.
going to harm the board.
Yeah, absolutely. And I've heard that before, and I've always known is because we've had positive energy there. But I mean, that just helps you understand that even our plug is designed to put a space between the wires so that they can't.
Right.
Right?
Exactly.
It was intentional. So we want to make sure that we're keeping those as isolated as possible, removing power. And when we're talking about DC voltage that is being supplied from a capacitor, it's very important to allow time for those capacitors to discharge.
Correct.
So if we're actually working on a live system and we're going to disconnect that plug, we want to make sure not only to kill power, but give it a minute, let that thing bleed
Oh, yeah.
down.
And the way to do it is to wait for the lights to go out.
Right.
And to confirm it, you can find a DC bus. And as long as you're 30 volts DC or below, you're good
You're
to go.
discharged. Yeah.
Should be safe. Yeah, because even 9 volts, I mean, won't kill you.
Yeah.
Put it on your tongue, it'll. 9 volts, all right. 30 volts, yeah. Telling you, we have a lot of fun.
So the last thing we'll talk about as far as diagnosing parts is LEVs. Realistically, LEV, that's our expansion valve.
Yeah.
It stands for linear expansion valve, but it's just like any other
Mhm.
EEV.
Yep, it's
right?
electronic.
So yeah, electronic. We essentially pulse 12 volts DC
Mhm.
to 4 of those 5 wires you see in a specific order. So one's a common, and then we're just sending a 12 volt DC pulse
right.
in a specific sequence to create that rotation, whether
Both
open
directions.
or closed.
Yeah.
So some of our LEVs on the residential side are about 500 pulse LEVs.
Mhm.
But once you get into commercial world, we're talking, we have LEVs that are 3,000, 5,000 pulse
6,000.
LEVs.
Really?
Oh, yeah.
So when
That's a lot of.
well, it speaks to how much control you have over the refrigerant.
Yeah,
right?
absolutely.
It's not
It's
any
refrigerant
longer
management.
of an open to close, right? Fully
Yeah.
open and fully closed is always going to be fully open to fully closed. If you have 5,000 steps to get there versus 500,
A lot of
the
control.
that you have over the refrigerant is just drastically different.
Wow.
So we've got 2 components, right? You actually have your solenoid, which is what's actually making that magnetic field in order to open and close.
Yep.
And then we actually have the body itself. So if we have a suspicion that we have a failed mechanical side of that LEV, we
Mhm.
actually have these donut magnets is what we call them.
Yeah.
And that will allow you to manually try to drive open and close that
Right.
LEV.
That's
And-
a lot of spinning on a 6,000.
Yeah. Do that because you don't know the opening.
Yeah, you don't
Right.
know where it's at.
And if you're not testing temperature, you could over open it and flood the compressor.
Yes.
Compressor. Absolutely.
Yep.
You always talk about, superheat. What is the best superheat? Slightly above zero.
Yeah.
but we have
At the
to be
very
above
least.
zero.
Yeah, at the
Yeah, we
very
can't
least.
get that
Yeah.
liquid back to the compressor. No compressor likes liquid refrigerant.
Right. And then if we're suspecting an electrical issue with the actual solenoid itself, we're just
Mhm.
going to ohm it out. And typically on our residential side, we're looking for 46 ohms plus or minus.
So from common to each one
leg,
of
yep.
the and
Yep.
I've actually encountered, I've only found one in my life. I had a system that would not modulate to 100% capacity. It wasn't yours, by the way. It wouldn't modulate to 100% capacity. It would only operate up to around approximately 80% capacity.
Yep.
And what we found is that one of the windings was actually bad.
Yes.
Right. So it would operate, but it couldn't open all of the way. And so it was only be able to modulate partially. And of course, what was the first thing that the technicians were doing when they got there?
Yeah,
Dumping
putting
gauges
gauges on.
Yeah.
Yeah. And not
Typical technician.
exactly.
Don't be the guy. Please don't be that
Yeah.
guy.
The last thing we need on these is to release refrigerant out of a system that is a sealed system, right? Let's figure out what's going on with it. And then if we feel like it actually has something in the refrigerant system, then we'll proceed. But, electrically, we want to make sure that we're checking those. So as long as we understand that if we've got 5 wires, we got common
Mhm.
and 4 coils.
That's it.
Yep.
That's really all we got.
Easy
Yeah.
peasy.
So those 2 should be the same, those 2, and those 2. And if they're the same, and if they're within 10% or so, then we should be good.
Go.
And one more point.
Yeah.
The coil to the body connection,
Yes.
it's open to the atmosphere
Oh, true.
and it will rust.
Okay.
It will affect the operation of the LEV.
So a service item.
Yes, on maintenance, make sure you pull the cap and look at it. If it's rusty, what would you use to clean it? Don't say anything.
Well, I used to
Or
keep
a
a lot of
screwdriver.
plumbers brushes around, but that might be a little bit of abrasive.
Steel wool.
Steel wool would
That's
be
what I was
fine.
gonna
Steel wool is the best thing to
Yeah.
use.
Okay, that makes sense. Absolutely. Get my pinky in there, a little steel
Yeah.
wool.
Yeah.
Keep-
Yeah.
All
Cool.
right.
So that's all we got for components. I know you were
Okay.
wanting to talk about some of the equipment a little bit.
Yeah, let's do that. And
Sure.
before we move out of here, is there any other slides that we need to cover while we're here?
Just the only thing we have left is just the training and where to find it.
Well, I
So,
think that's
you wanna
really
go over
important.
that now?
Yeah, let's
Sure.
do that now. And then that way, if we run out of time, we know that we've covered it. I want to make sure that you are connecting with Mitsubishi. I mean, when you start looking at the map, you go, wow, yeah, there's a lot of places out there. Well,
Right.
there are 11 that are actual corporate owned Metis facilities. And then there's 112 and growing distributor training facilities that have been authorized, right?
Correct.
Certified.
And certified to be able to produce. And we were talking about, I mean, it's the same equipment and it's the
Yes.
same curriculum. And the instructors go through a train the trainer so that they're producing the exact results that you would coming to one of the other facilities. They don't get the fun of hanging out with you guys. I mean, that's
no.
a whole nother
That
story.
they're missing 2 of the best.
They're missing that
Actually,
part.
3 now.
I'm telling you, Ty said he can't wait to get to one of these. I'm kind of the same
Yeah.
way.
So the nice thing about what we have going on with the authorized training centers, usually they're through our distributors.
Yeah.
So, and we have folks who work at the distributors who get qualified to teach the same classes.
Makes
All of our
sense.
training is standardized. So if you come to a class in Boston where I teach,
Yep.
or you go to the Ohio Training Center where Juan teaches, it's the same class. You're going to get the same material, same content, same handouts. So same
Excellent.
book, same way to take notes. So it's standardized across the board, which is great.
Yeah, I really like that idea of that standardized. It keeps that training consistent, keeps the learner
Yes.
outcomes
Yes.
the same,
Yep.
and so we're getting a lot of training. So just make sure that you connect with Mitsubishi, that you're looking at these different facilities, and that you're investing in yourself to stay up to date with the technologies and the equipment that is in the industry.
Right. Yeah. So if you are interested in signing up for training, you're going to go to MitsubishiComfort.com and you'll see the arrow there for 4 Pros. If you click on that, it will bring you to the next screen if you want to. And you'll scroll down a little bit. We actually just updated our website. So it used to be you click on 4 Pros and go to 4 Professionals. It was kind of hard to get to. So now we just have to click on 4 Pros. We scroll down to the contractor portal. We click on that. And there's a couple things that we can do here. You can create an account, and you basically request to create an account. That's where you can actually go into
The
signing up
trainings
for classes, see what's
okay.
available for classes, if there's any local to you, and how you can actually get registered for those classes. But we have a lot of free material, and
Yeah, a bunch of stuff.
realistically, a lot of the online stuff is free.
Okay.
Only classes are the things that we kind
The
of charge a
in-person
fee
classes.
for. Yeah.
Yeah.
So, but you don't actually have to have a login either for these videos that we put out on this Mitsubishi Comfort. So if we click on training from here, we have the find training, which is where you can actually find the schedule. And then if you see, we also have find media. So if we click on find media, it will actually show you all of the different e-learnings. And we also have these things called tech links. So these tech links are 5 to 10 minute videos where we kind of do something very similar to what we're doing
Right.
here. We talk some things that are just basic HVAC, like doing a triple evacuation, pressure testing, proper tools for the job.
Yeah,
things like
processes,
that.
procedures.
Yeah, but then we also cover some things that are specific to what we do and what products we offer,
Well, yeah.
and kind of how to get out of the jam of certain things that come up. For instance, our MHK2. Sometimes people get stuck in a wait screen, and we discuss, what do you do?
Right. How do you get out of here?
How do we get out of here?
Right.
Or how do I connect it in the first place? What are the steps for connecting that MHK2 controller? They're not long, they're very casual, and they're completely free and easy to access to anybody. You don't have to create a login, you don't have to do anything, but just visit the website.
I like that.
Yeah.
Be looking for further links and access to those. We want to make sure that we can share some of those, because we all like these short training videos.
Oh,
Right.
yeah.
This is very, very important stuff for us, especially in today's generation that loves our short form training.
Yeah. So, and as always, you've been a
Yep.
guest, so you're aware.
Yeah.
We have the Metis Tech Show. So it's a podcast that we all participate
Lot of
in.
fun.
You can see beautiful one, the second one from the left there.
And Bryn is the 4th from the left. No, yeah, it is the 4th.
Yeah, I'm hiding in
from
the
the
back
left.
on purpose.
Yeah, the one with the good-looking beard.
But it's a really fun podcast. We usually
It
start
is.
off by talking about food,
Yeah,
which is kind of our calling card thing.
I get it.
We're kind of running out of topics. Thankfully, you came along and told us about the turtle.
Oh,
that
yeah.
kind of helped us out.
We can, we'll do carp next.
Yeah. But it's a great podcast. It's usually great for your commutes, things like that.
Yeah.
So
How do you cut a steak could be one of our openers.
we're going to have to talk about it now.
Oh, yeah.
I like that idea. I really
Stay
like
tuned.
that. Yeah.
Cool. So that
Yeah.
QR code will bring you to the podcasts, the Apple Podcasts link. But we are on Spotify. We're on Buzzsprout, all that stuff. So
Excellent.
Yeah.
Make sure to hop out there and listen to some of the episodes. And I think we're going to try to use the AI camera. We're going to run around and look at some different inverter products while we're here.
Yeah.
And yeah, thank you, Ty. This is some really good stuff. Yeah, now we're starting to zoom. All right, so we're going to step back and take a look. Oh, Paul, by the way, steak knife in dominant hand, fork in the other. Oh, Paul, you would probably enjoy coming to here. There'd be some contrary conversations on that one. Yeah, let's go ahead and let's head on over there if you want to.
I'm
Yeah.
going to start here if you want to head over there.
All right, we'll see you in just a few minutes. Oh, hold on a minute. The camera grabbed him. The camera just absolutely loves
You want to
him
start
today.
over there? You want to start over there?
I think we're going to start
Yeah.
over here today.
That's a great idea.
All right, let's see how it does. All right, now we're following. All right, so follow us. We're going to head on over, and we're going to take a look at some VRF technology and learn a little bit about what's happening in the VRF industry. Oh, there it goes. I was going too fast. No,
Maybe it's looking for me.
it might be. Why don't you take over? It likes you today.
See,
it didn't.
come on, baby.
There we go.
All right.
All right, so let's talk about inverter technology. And this was a really good conversation. This is not just inverter technology for compressor, but inverter technology in our condenser fan motors as well. And I really like that idea. So let's dive deep into what's happening in the Mitsubishi VRF side.
So yes, besides the compressor
Mm-hmm.
being inverter driven, the fan motors, each fan motor has its own inverter board.
Separate boards.
Yes. So
Okay.
we have 300 volts DC coming into the board,
Yeah.
going through the inverter, inverting it into an simulated three-phase
Okay.
balanced AC voltage going to each motor.
So I could, from a service technician, I love this idea because if I had both of my condenser motors feeding into one common board and I had a board failure or a motor failure, I could lose everything.
Absolutely.
But now I could actually, if something happened to a motor or to a board, I could actually isolate a system, and now I have a full variable speed motor, so I can still modulate with capacity off from one motor.
Yes.
So I have, a lot of times when we think about redundant systems, we would have one that was a single speed, and then we'd have a variable speed to compensate for it. You're actually using two completely independent variable speed controls.
Yes.
For the two condenser motors on
That
this
is
one
correct. That is correct.
All right.
So what we have here is what we call the R2 system,
Okay.
which is a heat recovery system.
Yeah.
It's able to provide heating and cooling at the same time,
Right.
simultaneous heating
Through
and
different
cooling.
indoor heads.
You could have one head calling for heating,
Yeah.
and 49 of them calling for cooling.
Yeah.
It's going to provide heating to that one head.
It's the best
All right?
solution.
And we do that through two pipes between the outdoor unit and the branch controllers.
Okay.
So that's another topic.
Yeah, that's a whole
refrigerant
separate
flow.
conversation
Yes.
right there. I
And
like
then
that.
how we control capacity is
Mhm.
we segment the outdoor coil.
Oh,
We have 4 segments in certain models: 100%
yeah.
capacity, then 50%, 50%, and 25%. And that's how we
Wow.
manage demand,
Yeah.
by segmenting the outdoor coils.
Wow. So a lot of capacity control
Yes.
on this. And yeah, we should do another episode sometime when we
On
talk
refrigerant flow.
exactly. Yeah, because a lot of people don't understand what we mean. Because it's one thing to have a heat pump. It's
Oh, yeah.
another thing to have heat recovery where we can move heat from a space that doesn't want it. And instead of dumping it outside, we go put it into another space that would actually
That's what
like
heat
to have it.
recovery is.
Yeah. So it's back to heat pumping, but we're not pumping it outside. We're just pumping it wherever
Right.
we need it.
It is a heat pump,
Sure is.
but it's able to do that simultaneously,
Love it. Love it.
which a heat pump can't do.
Could you imagine if we can start putting them in residential applications?
Oh, I'm begging Mitsubishi to come up with one.
Except for those teenagers, we'd have to give them minimal
Yeah,
control.
we'll send them to the basement.
That's right.
All right, and
Okay,
then
what we're going to work on next? What we're going to take a look at?
we're going to go to Bren.
Let's
He's
do
going
that.
to talk about some of the residential equipment.
Okay, and if this camera doesn't like us, we'll head back over there. It was acting a little goofy on me earlier, so we'll see if it actually wants to track or not. No, it's not happy. So we'll be there in just a second. We'll see you soon. All
Thanks,
right,
Juan.
we're almost there. All right, so we're going to join Bren over here, and we're going to start talking about changes that are happening in the residential sector when we get into some of these more modern hybrid systems. Oh, yeah, we got a refrigerant chart with us as well.
So yeah, I mean, this is our IntelliHeat. It's our case coil.
Yep.
So, those have been around forever. What this allows us to do is use Mitsubishi platform, Mitsubishi outdoor units,
Right.
and have that case coil. It sits on top of a gas furnace, and we
Sure.
can now use a dual fuel system.
Okay.
So what I love about this particular system is our capacity balance point as well as our economic balance point. So this has a algorithm, has a learning capability where we set a balance point, but we never
An initial balance point.
Right, and that's temperature, just like any other case coil.
Okay.
But it also has a learning in it that will essentially, if we start to lose comfort, so if we have an issue maintaining space temperature after about 24 minutes, we'll start staging that gas. So unlike your typical heat pump where you're going to have either group points or something like that that has to be set through the thermostat,
Right.
it's all built into the system. So we don't need to do any of the traditional thermostat wiring. Inverter technology.
Yes,
So,
so
we
we're
can
able to
hook them.
use that inverting outdoor unit. Now we can actually attach it onto a cased coil. Because so if we think about that, it's a little different than we've thought of in the past. Because if we would think about a heat pump on a residential application, we're thinking about using a traditional cased coil
Right.
with with an outdoor unit. But since we're talking about like a ductless style outdoor unit that has the expansion, the LEV at the outdoor unit, so we actually don't even have a metering device in
Nope.
this coil because it's been managed by our outdoor unit.
Yeah, exactly. And the
really
other
cool.
thing I like is our heat pump, when we have our hyperheat hooked up to this.
Yeah,
So depending on what outdoor unit we choose, we're going to have different balance point options.
sure.
If we use a hyperheat, we maintain 100% capacity down to -5 degrees, and
Yeah.
we're still at about 73% at -13 degrees.
Wow.
So we can actually set balance points at -13 and say when that hyperheat unit just will not be able to keep up. Now we can stage that gas. So we're
Wow.
prolonging, right? We're prolonging the use of that fossil fuel. It's obviously
Absolutely.
going to be better for, greenhouse emissions, things like that.
Sure.
But as time goes on, and maybe the folks who install this have solar in their home where the electricity is just not as costly as it may be for somebody else. They
Right.
may want to. They may want to take full advantage of that hyperheat
And
technology.
just let it run.
Just let it run until
Yeah.
it just can't maintain that capacity anymore. So it's kind of a
Sure,
nice
it's the
setup.
best of both worlds.
Yeah, exactly.
And for those that are still stuck on dual fuel systems, which I am an advocate for dual fuel. I love having a high efficiency heat pump as well as gas in many applications. So that gives you the opportunity to look at your equipment and match the highest performing outdoor units with a good, maybe even the highest performing indoor unit in gas. Now you have a really good flexible combination that's a learning system.
Yeah.
At that.
Yep, absolutely.
Very cool.
And the last thing I'll touch on with this too is it also can be a part of our ported or branch box systems. So let's say you're in the market where you already have a gas furnace and you're already in the market for some ductless equipment.
Yeah.
You can add this as part of your
With multiple
as part
indoor heads in
Correct.
conjunction with your indoor cased coil.
Yeah. So in the sense that, I mean, personally, my house, we only had a ductwork run to our first floor
Yeah,
from our furnace.
Absolutely.
So my second floor didn't get any heating or cooling necessarily from that furnace.
Right.
So I may have been in the market to do ductless on
A
my
complete
second
separate
floor,
system, add an
but still
electrical to
have-
be able to run that.
Right.
Now you can just relook at using a single outdoor unit
Mhm.
and just adding an additional indoor head with line set.
Yeah. Yep. And you
All
can
right.
retrofit your old R22 coil with an IntelliHeat.
Look at that.
Yeah.
Yeah, because
Get the heat pump out of it.
you're actually talking an existing legacy wiring to the
Correct.
gas furnace.
Yes. So it's not communicating necessarily with the furnace. We
Right.
basically translate 24 volt or Mitsubishi communication with 24 volts, like your standard furnace.
Like an interface.
Yeah. So all we're really doing with this control box on the right hand side here is translating what our thermostat is asking
What's
for.
the demand?
Whether or not you are using a communicating thermostat or you want to use your Ecobee or Nast or
Yeah,
whatever, third party thermostat. We have the ability to do both. Either way, we are going to take in what we're looking for in that space
Right.
and determining, do we need to run our heat pump or is it time to run our gas? If it is time to run the gas, we are sending that 24 volt signal down
Back
from
to the
control
gas
box.
appliance.
So just like a standard furnace.
It's pretty simple.
Yeah.
Yeah.
Pretty straightforward.
All right. I know we're getting close on time. Have we got any questions? Let me take a look real quick and see if we have anything pop through. Yeah, Matt, that's all right. We're so glad that you joined us. All right. Any other products that we want to run through while we have the opportunity before we call it a day?
I think the only one we can talk about quickly is the Smart Multi.
Yeah, let's go do that real quick.
Yeah. So the Smart Multi, what I like about the Smart Multi is dual applications. So this
Okay.
is not just specific to residential or commercial. We can actually use a Smart Multi for residential applications and commercial applications.
Okay.
So if
So
we're
a single phase. So
Yep.
basically a single phase VRF system.
Yes, absolutely.
Okay.
So we get single phase up to 5 tons, and we can use that either with commercial heads, which commercial heads are powered separately. So typically for a
True.
homeowner, it's not the
Not
best
going to be the best
application to
fit.
go.
Right.
They may do a branch box, which is essentially just a distribution box. That's
Yeah,
where
yeah.
LEVs live. We can have up to 11 indoor units off of a single outdoor unit. And so now we got large houses.
Yeah.
We can use the smart multi for a larger residential application.
Oh, very, very cool.
However, we just came out with 6, 8, and 10 ton units that are 3-phase. So now we've also kind of covered some of that lighter commercial where we can use those commercial heads, but we're kind of filling that gap between a large, Y series or R2 system.
Yeah, with branch box and everything.
Yeah.
Sure.
So this is a
Very
great
cool.
product. I like that we can do both with it.
Very cool. So not just a technical training facility, but an equipment showcase as well.
Oh yeah, and it's all functional too.
Yeah.
That's the great thing. So
Yeah.
part of our training is all of this stuff is functional day 1, but day 2 we break it and we
Yeah.
have to fix it.
I love that. All right. Well, I think we're going ahead and wrap things up for the day. We're so grateful. Well, come on in and join us. We'll just kind of close things out from here. So it's been a wonderful opportunity to just get to explore our OEM equipment manufacturers and the training that is available for the industry. A lot of times as educators, we feel like we don't have the same access to training that a contractor has. And here is the proof that they want you to come and learn about this equipment, partake with training,
Yep.
and just help move this industry further. So make sure to connect with Mitsubishi, get your butts in these classrooms, come see us at the National HVACR Education
And
Conference.
never stop learning.
And never stop learning.
Don't fear the inverter.
That's right. Don't fear the inverter. Inverters are for everyone. All right, everyone. So thank you for joining us. And we will see you again next week on Did You Know? The ESCO HVAC Show.